Hey everybody, so today we are going to talk about similar figures. I want to tell you, I think we decided that we should have done this before similar triangles. This stuff right here, honestly, is probably going to seem like kind of a review because we've already talked about a lot of this stuff when we talked about similar triangles. So, similar figures come down to basically this. It's the same shape, just a different size. It's bigger or smaller. It involves a scale factor. Remember that scale factor is the new over the old. That's how you find scale factor. For example, a square that is this big, if it is a square, it means all the angles and all the sides are the same on this one, would be similar to a square that is much, much larger than it because all the angles are the same and all the sides are the same. So, for our first little thing here, we're going to take a look at this picture, or we're going to look at this situation. We're going to draw some trapezoids. So let's draw a small trapezoid, and we'll draw a larger trapezoid. Trapezoid looks something like that. All right, and so we have SIMA, SIMA, and LURE, similar, but they're not. Okay, LURE, sorry for the bad pun. So we have this angle because of this. Right here, this tells us that angle S and angle L are the same angle. That angle and that angle have to be the same. Also, we know that this, because I and U are in the same location, this angle is the same as this angle. We know that since M and R are in the same location, this angle is going to be the same as this angle. And then finally, A and E are in the same location, so this angle has to be the same as this angle. All right, so basically what that means is if two polygons are similar polygons, the corresponding angles are congruent. They have to be the same. Now, the sides are the angles are congruent. The sides are actually proportional. So for our symbols over here, we can say that angle S is congruent to angle L. You can just look here at the similarity statement. We can say that angle I is congruent to angle U, excuse me. I goes with U, M goes with R. Angle M is congruent to angle R. And angle A is congruent to angle E. But we can also say that the sides are proportional. Okay, so this is a little trickier, but we can say that SI over LU, that is the same as, that'll be the same fraction, the same ratio as IM over UR, and that'll be the same as MA over RE, and that'll be the same as SA over LE. Okay, all the sides will end up being proportional in a similar figure. We already talked about triangle similarity, and when that happens, the fact that the sides all have to be similar, or have to all be proportional, and the angles all have to be the same. So let's take a look down here. We're going to take a look at this situation going on right here. We're going to talk about the fact that scale factor, the scale factor again is new over old. So what we're going to look at is we're going to look at these two triangles. We have to figure out, are they similar? Well, we did this today in class. Remember, you take the smallest side from one triangle, which in this case would be 49, and put it over the smallest side on the other triangle, which would be 14. This side corresponds with that side. And then you take the let's see, the largest side on this triangle, 98, and put it over the largest side on that triangle, 28. And then you take the leftover side, the only side that's left here is 84, and the one left here is 24. And we want to see, are these triangles actually congruent or not? Okay, because that's kind of a big deal. If they're not congruent, then we can't do anything with this. So, sorry, I was trying to locate my calculator. If I divide these, 49 divided by 14 is 3.5. 98 divided by 28 is 3.5. 84 divided by 24 is 3.5. Every single one of those is the same. These are all equal, so these two triangles are in fact similar. All right, so we can now say, since they are similar, we can say, see it says UTS is similar to, triangle UTS is similar to triangle, now U is this angle right here. It's between the smallest side and the middle side. Well, on this triangle, that would be E. So we put E there. And then on, let's see, it went UT, so U to T, it went through the small side. So from E, I'm going to go to F, and then the only place left to go is to G. Now here's the problem finding the scale factor. The scale factor is the new over the old. Well, this does not really tell us which one is the new one and which one is the old one. But I'm going to make a decision that since it said this first, I'm going to assume that it was meant that this be our original shape, or the old one, and this is our new one. Okay, so what we do to find the scale factor is you pick any of these sides and you put it over the corresponding part on this one. So I'm going to pick 14 because it's the smallest number, and that means I've got to reduce less usually. So I'm going to use 14, and 14 corresponds with, we'll see that's FE, that's the first two letters, that's UT here, so that would be 49. We already knew that though because it said so right there. All right, but it's 14 over 49, not 49 over 14. Now I need to reduce that to find the scale factor. So 14 divided by 49, hit enter, and then hit math, enter. And it reduces down to 2/7. Our scale factor is 2 over 7. The shape got smaller. To get that number, you could multiply 49 times 2 and divide by 7, and you get 14. That's how that works. All right, let's take a look at this next one. All right, we are, in this case, I have figured out, we are to assume that these are similar. It doesn't come out and say it, but we are supposed to assume these are similar shapes. And we're supposed to figure out what this is. There's a question mark there, and there's a question mark there. So taking a look at this one, okay, we can see that this is supposed to be set up correctly. Again, I'm not a big fan of problems like this when they don't actually label things the way they should. I wish there was a B, C, D, and E, F, G, H, and there was a similarity statement written, but there's not one. So we're going to have to take this as what it is. All right, we're going to take corresponding sides. This side would correspond with this side. So I'm going to do 12 over 18. That's going to equal, I'm going to take this side, question mark, or X, and put it over this side, 24. Okay? And then we would just cross multiply that. 18 times X equals 12 times 24. 18x equals, let's see, 12 times 24 is 288. 12 times 12 times 24. I'm pretty sure it's 288. It is. Equals 288. And then I would divide both sides by 18. And x would be 16. All right, so that is how that one works. For this one, again, not a big fan when they don't label things, because honestly, like this, I always tell my students you can't go by the way things look, and yet here I'm supposed to go by the way things look. I don't like that. So I'm going to mark something. I'm going to put this one and this one go together, and I'm going to put a right angle there and a right angle there, and 2 arcs there and 2 arcs there, and 3 arcs here, 3 arcs here. Okay, so now I can say, okay, that 14 is between the right angle and the 1 arc. That corresponds with the question mark. And the 8 is between the right angle and the 2 arc. That corresponds with the 4 on this one. And so we would again cross multiply. We get 8 times x equals 14 times 4. And 8x would equal 56. Divide both sides by 8. X is 7. That's all you do. Okay? Again, not a fan when they don't have them labeled. So I'm just going to label them myself from now on. Because again, you cannot go by the way things look. You have to go by the way they're marked. Another prime example right here. If we are to assume that these triangles are similar, then we need to have something marked that says so. So I'm going to have an arc there and an arc there, and 2 arcs here and 2 arcs here. Now they're similar by angle, angle. All right, so I need to set up a proportion. Now, real quick, since we're going to find x, we have to use this side. Okay, we have to use this side. So I'm going to make my proportion 4x minus 4. That's going to go over the corresponding side over here. Now, 4x minus 4 is between the 1 arc and the no arc. So that would be 30 on this one. And then I can pick either one of these. I'm going to pick the 24 because it's smaller and it's easier to multiply by than 48. And 24 is between the 2 arc and the no arc, and that would be 20 on this one. So there that is. So now we just cross multiply. We get 20 times 4x minus 4. It's going to equal 24 times 30. (24 times 30 is going to be 720. When I distribute this, I get 80x minus 80 equals 720. I would add 80 to both sides, which will turn this side into just 80x and this side into 800. And then I would divide by 10, 80. What am I saying 10? You divide by 80 and x would equal 10. That's what it would end up being. So that is how you would do that one. As for this one over here is one of the tough ones. You're going to want to use a calculator. I do not want to have to go through and teach you quadratic formula again, or factoring, or any of that stuff that a lot of you did not get the first go around. If you'd had Algebra 2 by now, you would know it. But I don't want to go through all that stuff, so I'm just going to set this up. But real quick before I do, let me do some marking so we can say these triangles are similar. There, they're similar now. So I'm going to say that 3 goes with the x, because it's between the right angle and the 1 arc. And then x goes with x plus 6. All right, so cross multiply this, I get 3 times x plus 6 and x times x. Now, I'm going to tell you right there, because those two x's being multiplied together, these triangles are going to be, or these triangles, this is going to be a parabola. So, to save myself the trouble, I'm going to go into my calculator and I am going to use it to find my answer. Yeah, it may be lazy, but again, I don't really have a lot of time to teach everybody how to do algebra. We still have a lot of geometry to cover. So what I do is I put this side into y1, I'm going to put that side into y2, with parentheses and everything. I'm going to go to my table, and I'm looking for when these two things are the same, and there it is right there. The answer is 36. No, it's not. I apologize. That's 36. That's 36. The answer is 6. X equals 6. Now, it actually has another answer, and that's usually in the negative. Let's take a look to see if it is. Ooh, I don't know that it is. Let's see. Oh, yep, there it is. -3. But -3 cannot actually be one of the answers because this side right here cannot be -3, nor can that side. So that doesn't work. It can't be -3. Algebraically it can be, but realistically, this is geometry. We're dealing in real things. It can't be -3. So it's going to be x equals 6. All right, on to this one. When you have one like this, folks, the best thing I can tell you to do is separate your triangles. Do not try to do this without drawing your big triangle and your little triangle. Now, we're going to, again, assume these are similar. I'm just going to do a right angle there and a right angle there because this is a shared angle, so that right there tells us they're the same, or they're similar, rather. All right, so I see that this is 12. This is 9. This is 6. This is x. This is 11. Now, I have to use the x. So x, if that angle is the same as that angle, and that angle is the same as that angle, x corresponds with 12. X over 12. So I use that one and that one. And I can't use 11 because I don't know what that is. So I can use 6 and 9. And then I would set them equal to each other. And I'd get 9 times x equals 6 times 12. And that'd be 9x equals 72. You divide both sides by 9, and x equals 8. There it is. And as for this one, again, if it doesn't tell you, you can't just assume, but I'm going to say that, you know, this angle is the same as that angle. And we already know that's a shared angle, so these are similar now. But again, I've got to separate them. There's my little one. And my bigger one. All right, on my little triangle, trying to see here, wait a minute. I believe this is supposed to be 27, if I'm reading that correctly. This is 39, this is 4x, it looks like. This is 80, this is 130, and this is 90. So I have to use 4x, and 4x corresponds with 80. And so now what I have to do is I have to pick which one of these do I want to use. Do I want to use 39 or 27? Or better yet, do I want to use 136 or 90? I want to use 90. I don't want 136, that seems a bit much. So what I'm going to do is I am going to, sorry, I was just looking at something. I'm going to use 27 and 90. So since I did 4x over 80, I do 27 over 90. That's going to be my setup. So I have to cross multiply these. I get 90 times 4x. That's going to equal 27 times 80. 90 times 4x would be 360x. And 27 times 80, I don't know what that is. Give me just a second. 27 times 80 is 2,160. The next thing I would do is I would divide both sides by 360. And then this side will just be x, and this side will be 6. So that is similar figures. I know you're looking at those last 4 problems and going, those are similar figures, those similar triangles. You're right, they were, but a triangle is a figure. Sorry the video ran a little bit long, but there's a lot to that. Hope it goes well and we have a good day in class. So.